Buenos noches. That's all the Spanish you're going to get out of me, which is particularly ironic because my wife is Bolivian and is fluent in Spanish, and one of my sons majored in Spanish in college. But unfortunately, I'm a single language guy. A little bit of French, but it's weak. In any case, I'm here tonight to talk to you about a mutual passion of Alex and mine, and that's digital identity, but specifically self-sovereign identity. How many of you have heard that term before, are familiar with it? Okay, so it's starting to get out there. I was one of about 3 years ago, one of the people that were discussing what we were going to call this new kind of identity. And this term self-sovereign was used. I didn't think it would catch on at all. And yet it did. It's become the term that people use to talk about it. And so my goal here tonight is to explain to you why. Why is this term really taken off? First, a little bit of background. I have been working in digital identity and internet identity for longer than I want to admit, 20 years. Okay, pretty much my whole career. I've been involved with a bunch of different standards organizations, and there's a event, Alex has been there, called the Internet Identity Workshop. It's a 3-day event that's all open space, meaning there's no agenda. You come together, about 200 to 250 people, and they create the agenda every day. This has gone on every 6 months for 13 and a half years. That's how big of a problem digital identity is, and I've been to every one of them. Now, I wear a bunch of different hats, and I'm not going to explain all of these. At the company Evernym, I'm what's called Chief Trust Officer. And then at the Sovereign Foundation, I'll explain I'm one of the trustees, and I chair something called the Governance Framework Working Group. I'm going to explain what that's about. And then I work on a bunch of the different standards in this space. And I'm going to talk a little bit about them. How many folks in this room are really technical? You're developers, or you like to go down deep? Hands? Okay, a handful. And how many of you have never read a line of code? Just kidding on that one. Anyway, I'm not going to go very technical. I'm going to talk about technical things, but if you have technical questions, there are some areas where I go pretty deep. I'm not a developer myself. I work on the protocols and the standards, but we won't go too deep on that. Okay, so first I just want to make sure, I'm going to talk about a few different entities. I want to make sure it's clear. So Evernym, the company I work for, is a commercial vendor of solutions in this new space of self-sovereign identity. We are building up products that we're going to sell to enterprises and governments that want to use this as a new identity tool. And also we serve individuals who want to have self-sovereign identity. Most of the services for individuals we think will be completely free. They might even pay you, right? You might have a way of capturing the value of your identity. But that's what we do as a company. I'm going to talk about sovereign. How many folks have heard about sovereign in this room? Okay. It's a global public utility that we've set up for this purpose of self-sovereign identity. And I'll explain that as we go through this. And then I'm going to talk about Hyperledger and Hyperledger Indy, which is the open source project that Sovereign helped start at the Hyperledger Foundation. How many folks are familiar with the Hyperledger Foundation? Is that, yeah, some? Okay. All right. I just want to make sure those are clear, the differences in those. All right. So self-sovereign identity is quite a story. Most of you have probably seen this cartoon, right? Do you know how long ago that cartoon was published?
20 years?
More than 20 years. 25 years ago, 1993. Surprising fact, it is the most reproduced cartoon in New Yorker history by quite a bit. When we licensed it for a Sovereign Foundation white paper, the person we talked to at New Yorker said more than about a third higher than any other cartoon, this one. It's because it speaks to such a deep problem on the internet, right? I mean, it can be looked at as an advantage. There's actually a Wikipedia page about this cartoon. It's good reading. It talks about, hey, you can be anonymous on the internet, right? You can be a dog. And that's an advantage, but when you actually need to prove your identity about something, it's a disadvantage. And it just speaks to how far the problem goes back. interestingly enough, the Internet Identity Workshop turned around and with permission, created that logo for the workshop. So it's how far around it is. Now, I'm using the term self-sovereign identity, but you also will hear it talked about as blockchain identity, in a very general term, or decentralized identity. All three terms are used, and they pretty much mean the same thing. Okay, there are some companies out there that talk about blockchain identity, and they have somewhat of a different picture, but pretty much folks have converged on what I'm going to talk about tonight. So the easiest way to explain why this is a watershed, a revolution in digital identity is by explaining the three steps that we have gone through, the three phases we've gone through in digital identity, particularly for the internet, okay? The first one is very easy to understand. You create an account at in a network, at a website, in an application, okay? Who has created a new account in the last 24 hours someplace? Yeah, okay. This is just the point. We do this almost every day, right? New username and password, something new to remember. Another question I love to ask audiences, how many of you use a password manager of some kind? Okay. Okay. I'm not talking about the one in your browser, most of us use that, but a separate program. Okay. It's a pretty good example of just how much pain is involved. When it was just your own network, your own internal network you were logging into, and you had a couple usernames and passwords, it wasn't a big deal. But when we got on the internet and we needed a new one for every site, I mean, I've heard people compare their lists, and the largest I've ever heard is about 1,200 usernames and passwords, but a lot of us have several hundred, 300, 400, 500, okay? Even just to do this required 7 years of standards creation just to create the encryption between you and the website to do this safely, to log into websites, exchange information. And by the way, you are a dotted circle here because you, as an individual, do not exist on the internet without an account someplace, right? You create an account every place you go, and that becomes your presence on the internet. You don't have any independent presence under this model. So as the number of usernames and passwords exploded, and the overhead on that and all of the, all the attendant problems, what happened was we evolved the second model, which is called IDP, Identity Provider, or Federated Identity. And the way that we proposed to solve the problem there was stick a service provider in the middle. You logged into them, you created an account with them, and then they could connect you, log you in every place else. I suppose almost everyone in this room, I'm not going to ask the question because most people won't admit, do you use a login with Facebook, login with Google or Twitter or LinkedIn? All those buttons you see on websites that let you log in with that one button, it's this identity provider. You go to this site and they provide a button here, and if you click that button, it just bounces you over there and says, yeah, you're logged in, bounces you back, you're in. And maybe they can share a little bit of the data that you've stored there. When you do that internet-wide, it's called social login because you're using a social network. But this same model, most large corporate internets or extranets use this. They call it single sign-on, right, to all your applications. It's actually involved 3 generations of standards that took 15 years to develop. And unfortunately, I came in when this one thing was being developed and was involved in the development of all of those, so I've been through a lot of the pain of that. As much as it looks like, hey, this can solve the problem, and there has been significant adoption of this, it actually has sort of hit the wall in terms of really solving the problem of digital identity. One of the reasons is there's no identity provider that connects to everyone. Okay? No matter who you connect to, even if it's Facebook or Google, there are only so many places. We deal with hundreds of banks and what we in the US we call credit unions. Not a single one will let you log in with Facebook or Twitter or even Google. right? It's not secure enough. Second problem is all those logins are not portable. If you log into 100 websites with Facebook and you're doing great and then you decide to close your Facebook account, or worse, Facebook kicks you out, you lose all those connections, okay? You're also limited to whatever is supported by this identity provider, and that generally is a pretty low bar. So federated identity, it's been a good 15 years. It's gone a long ways, but now we're moving to the third generation, the big shift, and that's self-sovereign identity. Now in this model, we go back to just you and the other site. But you are no longer a dotted line. And this is no longer an account. If I get a business card here, and I hand it to Alex, and I say, Alex, good to meet you. I don't say, Alex, thanks for forming an account with me. Or vice versa, right? We have formed what LinkedIn calls a connection, right? It's a relationship, and you and the other peer that you're connected to are equal parties to that relationship. That's how it works in the real world. This is how it should work online. So, yes, you're seeing down here, oh, blockchain's involved. So how do we make this? Why is blockchain the key to this whole new watershed of digital identity? This one slide, it took me a couple months to develop this. The whole story's on this one slide, okay? So, part number one, click. This is when I get out my first most favorite prop. Ladies and gentlemen, decentralized self-sovereign identity. Every one of you is using it every single day. The only thing is, it's not digital. If you want full self-sovereign identity, we need to take this and we need to put it on this. Now, the key is, what makes this work is, yeah, I own and control this wallet, and if I took out all these credentials and just walked up to the TSA to get, the airport, and just handed my wallet and said, yeah, here I am, I wouldn't get on a plane, right? I have to have a credential from some issuer that they trust, okay? Same thing true here. I have this self-sovereign identity wallet. I've got some credentials in there, but if I'm going to use them to be trusted, I could create a business card like I did with Alex. That's some trust, but it's not going to get me on a plane. So if I want to get a credential to put in that digital wallet, I need to get it from some other peer. Now, why is blockchain making this possible? It's because that credential is going to be signed by a digital key on a blockchain. Almost always a public blockchain. Which means that when I need to go to a site and present that credential, that other party over here, whether it was the issuer or anyone else, can check that key on the blockchain and verify that signature. Now, if we use a public blockchain for all of those keys, that means any issuer of a credential can issue it to anyone, and any other verifier of that credential can verify that signature. We'll have a globally interoperable public key infrastructure. I don't know how many folks are deep in crypto and public key infrastructure, but we call this decentralized PKI, decentralized public keys. And it is the essence of why this works, why we can finally have self-sovereign identity. I'll leave this here because I guarantee you I'm going to get back to it as a prop. I'll even leave that one right there too. So, to make this work, we actually need 4 new standards, and I'm just going to click through them. First of all, how do you find a public key on a blockchain? The standard is called DIDs, Decentralized Identifiers. I'll talk more about it down into a minute. I'm the co-author of this specification. It's at the W3C, the World Wide Web Consortium, and they are just about to form a full working group at W3C because they've decided it is the most important new identifier, type of identifier on the internet after the web URL that you use in your web browser. So first we need that standard so that we can get to those keys. Secondly, we need for this to not be locked into this. Is anyone in this room not using either iPhone or Android phone as a smartphone? Everyone is using one of those two. So every one of you has a wallet on your phone today that can accept a set of basically usually credit cards or other things that's proprietary to Apple or Google. It's not portable at all. The second standard, called DKMS, Decentralized Key Management, is an open standard so that you can't be locked into your wallet any more than you could be locked into your bank, right? How would you feel if there were a bunch of proprietary banks out there, and if you picked one bank, your money was stuck there, right? Your digital identity arguably is as important or more important than your money, and it should not be locked up any place. So that's the second standard. Now with those two, the third one, it's called Identidad, is the way that anyone holding a digital wallet should be able to authenticate, meaning prove your identity any place else. It's really me. No username, no password, more secure, more private than all those systems. W3C is already jumping up and down on that one. And the last thing we need to make this work is that the exchange of those digital credentials has to be interoperable, right? The credential going to my wallet and a site that I go to read it, they all have to understand, here's what it looks like, and here's how it's signed, so I can verify the signature. That last one has been a W3C, Worldwide Web Consortium, working group for almost 2 years now, and it should be done in the next 6 months. So, and all the rest of these, they're operating versions of this. So we have most of what we need, because we've been working on it over the last couple of years, to make self-sovereign identity a reality. That's why what I'm talking about tonight is not theoretical. We're going to talk about some examples of how it's coming out into the world fairly quickly. So, again, by the way, all these slides, this whole deck is public. You're welcome to take pictures, but we can also share it with you. And Alex has actually done a webinar where most of these slides exist on SSI Meetup. All right, so now I want to summarize here. If you're like, wow, that was a complicated picture, remember, it boils down to this. Self-sovereign identity is getting your wallet on your phone, but not a wallet of money, a wallet of identity credentials. Now, you might be sitting there wondering, well, am I going to need one wallet for my identity credentials and a different wallet for my digital money or cryptocurrency? Well, a lot of folks building wallets are starting to go, well, no, you shouldn't, any more than I need two wallets here, right? I got money, I got credentials, they go in one wallet, I keep it in one pocket, everything's happy. I believe that's going to happen, that we're going to have wallets, they're going to be combined, they're going to be mobile, you're going to have a wallet on your phone, your tablet, your laptop, in your car. All your devices are going to start to come with wallets that are interoperable, and which, you set it up once, just like you get a new device, you set it up once. Okay. Now I'm going to go a little deeper. I'm going to explain a little bit more about the pieces that go together to make this work. And then we're going to go into, okay, so how's this actually evolving out there in the market? Oh yeah, I covered this point. And remember, and when you're wondering, why is blockchain the key to self-sovereign identity? You've noticed in everything I've said tonight, I haven't mentioned cryptocurrency at all. There's nothing about the use of blockchain for what we're talking about self-sovereign identity that involves cryptocurrency. However, it's highly complementary to cryptocurrency. Many times when you want to exchange cryptocurrency, you actually want to be able to prove your identity, or at least prove that you're trusted. So these two things are complementary, but there's nothing about self-sovereign identity that requires or builds on having to have a cryptocurrency. Okay, so a little bit about these DIDs, these decentralized identifiers. And I know I'm talking about something here that seems like, it could be a pretty technical topic. It is a little bit technical topic, but I want to personalize it. How many folks recognize that identifier? I'm curious if there's anyone in the room that recognizes that. This is good. I love this international test. If we were in the US, 99% of the folks would pop their hands up. That's a social security number in the US. That is the identifier you're issued when you are born and registered with the US government. It's not mine. In fact, I use this particular one because there's a Wikipedia page about it. This one's been used by 40,000 people. How did that happen? Back in the 1930s, a company called Woolrich in the US. The CEO, they wanted to sell a new wallet, and it had one of these windows in it, so you could put a credential in there and you wouldn't have to take it out. And it was a new idea at that time. So the CEO of the company said, what are we going to put in there? Let's put a social security card, the card that you get that has that number on it. And but let's not put a real one. So he asked his secretary to just create a little miniature social security card, and she used her social security number. Printed it on that card, and they sold it with the wallet. A whole bunch of people bought the wallet, looked inside and said, oh, I have a social security number. And they just started using it. The point being, how do you prove in the United States that that's your social security number? You get a little card, which is so easy to any laser printer could produce a version of that card, right? There's no protection behind that at all. As a result, about 8 months ago, when we were talking to the US government, we were holding a workshop for federal government agencies in the United States, and the IRS, the Internal Revenue Service, collect taxes in the US, had been doing their homework, and they were really interested in blockchain. And they came, and we showed them this, and we said, okay, if we could replace that number as a way to identify yourself with the US government with a longer number, not one that you're probably going to write down, but one that you could use to sign your tax return, they could save $20 billion a year in hacking of US federal tax returns. They believe 90% of that is actually going over to Russia. So we wouldn't have to finance them to interfere with our elections. So why is this number something that the IRS would be so interested in? What's different about it than a social security number? It's because, as a DID, it's the address of a public key on a blockchain. This particular one is the address on the sovereign blockchain. But if you put BTCR there, it's on the Bitcoin blockchain, or ETH, it's on the Ethernet blockchain. It's an open standard that can be used with any modern public blockchain. And it's the address of the public key, and you hold the private key wherever you want your digital wallet. In fact, all your digital wallets will have the private key. Now, you can look at those numbers and know right away. You're not going to memorize any of those, okay? Which might seem like a problem until I turn around and ask you, how many phone numbers in your address book do you remember these days? I mean, who in this room thinks they remember more than 10% of the phone numbers in their address book, right? If someone asked me for the phone number of a friend, I don't have a clue, right? We all have to get out our phones and look it up. We already don't even track phone numbers. This is just a little bit longer number, but this easy for these things, okay? So fundamentally what a DID is, it's a new standard, open standard for how you have the address of a public key for which you keep the private key, which means that if I tell you this is a DID, I can prove it to you. I can cryptographically sign it with a private key, a message to you, or a message you send me. And you know it's me as the control of that private key, okay? That's the basic idea of DIDs. Now, here's the thing. You won't have just one. It's not like that social security number or government identifier where you're only supposed to have one, right? Entirely different. You will actually have thousands of them. And the reason is you will have one for every relationship you set up. There's no need, with a phone number, it's only practical for me to have one. I share that phone number out there. Everyone has a copy of it. Do you know what identifier you are tracked the most with in modern digital life today? It's not your government ID, not even close. It's your cell phone number. You notice how many more websites are asking you to share your cell phone number than your email address? This is the one true identifier they're using to track you today. Sometimes they need it, but many times they don't. It's just the fastest way to access databases out there of your information. So with DIDs, Your wallet, your digital wallet on your phone, on your tablet, any place else will generate a new one every time you create a new relationship, a new connection. Okay? You don't have to think about it. It's just like an address book that's automatically filling up. So that, we call this privacy by design, done at a global scale. It's building in the ability for you not to be tracked unless you want to be. Unless you say, yes, I am the same person that's in that other database over there. Okay, so that's one thing about DIDs. The other one, which is really important, remember that connection that the two peers formed? Every time I hand you as another individual, or a business, or a thing like my connected car, a DID, they hand me one too. We call them pairwise pseudonymous identifiers. Now, the other thing that DID is associated with is what we call an agent, an endpoint to communicate. What that means is every time we share DIDs, we are creating a private encrypted channel between those two parties, two people, person or organization, person to thing. I can't emphasize this enough. There has never been a connection like that in history. There is no intermediate service provider in there. There's no telephone company, no internet service provider, no social network. It's direct peer-to-peer between the two of you. And those DIDs will last forever. You have your own private channel to use for as long as you live. And in fact, as long as needed to, even for your digital estate. So again, there's never been an identifier like this. This is why the W3C has said, oh, we have to standardize on this. This is the first identifier beyond the URL that is important enough to the future of the internet that we're going to get 400 companies together to agree on that standard. And we think it's largely done, so it's mostly just a bunch of politics. Once more, I want to emphasize, DIDs are not specific to Sovereign or Bitcoin or Ethereum. They can work on any blockchain, public or private, from now and for many years forward. It's very simple, but as an identifier, it's globally unique, doesn't require any centralized authority, and it's cryptographically verifiable. Those are the three properties that we've never had before. All right, that's all I'm going to do on DIDs. Like I said, it's a little bit technical, but I want to make sure you understand the business implications. Now let's talk about the digital equivalent of these, verifiable credentials. Click. So that's the term. I know I often just call them credentials or digital credentials. They're called verifiable because they have a digital signature that you can verify. This is, as I said, a standard that's been 2 years in the making. It's getting close to being finished, and it will be an official W3C standard, which means any company, any place will be able to build the software to create a credential that you can sign and someone else can verify. We've never had that before either on the internet, which is why it's a pretty big deal. Now, I want to quickly explain the basics of how this works, because if you walk away with one thing here tonight, it's like, oh, self-sovereign identity is digital credentials that will work any place. And then you'll start to think about it, and pretty soon you'll go, oh, it's way more credentials than just the ones I carry in this wallet, right? Everything that one person needs to prove to another person is something that can now fit into that, right? It's going to be a much wider variety of credentials. All right, now I'm actually going to take out a credential to do this. Like I said, very handy prop. So this is a driver's license. In the US, we have 50 states, and that's the only place you can get a government ID card. In the United States, you cannot get a federal ID. You can get a social security number, but they will not give you any form of identification based on that. Unlike in Europe, where you get government IDs and people trust them and use them, those crazy people in the United States, they don't trust the government to track that kind of information. So we have state-issued credentials, identity credentials. So today, for me to get this piece of plastic, I have to go to the Washington State Department of Motor Vehicles and prove who I am, give them various pieces of information, and finally they say, okay, you qualify, we're going to give you a credential, and I put it in my wallet, right? My physical one. And then I go to the airport and I take it out and I give it to the TSA, and they look at it and they run it under a black light and they say, okay, that's a valid driver's license, you can get on the plane. Issuer, holder, verifier. That's how it works in the physical world. So the digital process is Washington State DMV, before they issue the digital credential, they go and they register one of these DIDs on a public blockchain. Okay, public DID up there. Now they're all set, and when I come in and I prove to them I really am the person on this credential, they can give me the physical credential and they can issue me the digital credential into my digital wallet. Okay? So now I've got it in there. Now I can show up at the TSA, and how many people have used a mobile boarding pass on your last plane ride? The process of showing them a digital driver's license would be exactly the same thing. Pop open your wallet, there's a QR code, they scan it. In less than 2 seconds, they will have verified that that's a valid driver's license from that issuer, or from any issuer in any state or any nation in the world. Just needs to be signed by a DID on a public blockchain, one that's pretty robust. Make sense? You see how that works? Okay. So again, DIDs and a standard format for the credentials is all we need to make this work. Now, I'm going to go a little bit deeper. At least I'm going to explain 2 more things in technology that are important to understand the business and the policy implications of as we look at this infrastructure. And these 2 things I'm going to explain are specific to sovereign and what we're doing with the sovereign network. This is the overall, they fit within this, but if we go specifically to say if it's sovereign, then the first feature is what I mentioned earlier. Whenever you create these relationships, you go and you sign up at the driver's license authority or go to TSA, we create pairwise synonymous DIDs, which means that even though the Department of Motor Vehicles needs a public DID, you do not. You just create those private things. You have the private channels. You're issued this over a private channel, and you show it over a private channel, and that helps protect your privacy. You don't have to put a big beacon out there that you're being tracked around with. Okay? The second one is even more important, and that is that we standardize the issuance of these credentials and the presentation of these credentials on zero-knowledge cryptography. Is that a completely foreign concept to everyone, or we got a bunch of zero-knowledge folks in the room? Okay, yeah, little bit of both. The basic idea of zero-knowledge cryptography is that cryptographically you can prove that you know something about some data without revealing the data. The classic example when it comes to something like a driver's license or a passport is that I can go into a drinking establishment, I can prove that I'm over the legal drinking age without revealing my birth date or anything else on the credential, right? Zero-knowledge cryptography is not new. It's been around for, 30 plus years. It is now being used in some cryptocurrencies like Zcash and Monero. But now we're saying there's a very practical usage for it, which is in fact one of the things that GDPR, the global, the General Data Protection Regulation in the EU encourages, or it doesn't exactly mandate, but it strongly recommends minimal disclosure of information. That a verifier should not ask for anything more than they really need to know. Well, the beauty of using zero-knowledge cryptography is that when this credential is issued under zero knowledge, you actually share a secret with the issuer that it uses to encode that credential when it goes into your wallet. You are the only one in the world who can now produce a proof of that credential to a verifier. That credential can't be copied to another wallet. That is what's called the link secret that's in here. You're the only one who can produce it, and the verifier can verify that you're the only one that can do that. So we're increasing your security and your privacy at the same time, okay? And that zero-knowledge cryptography, again, if it sounds, it was pretty cutting edge 18 months ago when the Sovereign Foundation made the decision to do that. It has since been recognized as this is what should be done. The European Commission has already said, hey, sovereign, we think you're doing the right thing. Everyone should be adopting this for digital credentials. The underlying technology, by the way, was developed both by IBM and others around the world, but IBM Zurich Research Labs had a quite robust implementation that they finally open sourced. That's what we're using for this. And the inventor of it, Jan Kamenisch, for any of you deep crypto heads, joined the Sovereign Technical Governance Board because he realized finally his life's work, he'd spent 17 years on development of technology, finally it had a way to get broadly adopted and to help every person on the planet protect their privacy. So it's a pretty big deal. It's something that is currently unique to Sovereign. We are actually, the code is in Hyperledger Indy, and we're encouraging other self-sovereign identity and blockchain projects to adopt it. All right. So I think that's as far as we go down into serious crypto. I put these slides in here because if there's anyone out there, I always get the question, okay, so I've got this whole digital wallet on my phone. It's got all this super important information on it. What happens if I lose my phone, right? What happens if it's, or it gets compromised or hacked, or my kids take it over, right? Critically important, of course, if your digital life is going to be captured there. So I'm not going to go deep into DKMS, but I am going to just answer that question right up front. Again, this is an open standard that's emerging. The research on this was actually paid for a research grant from a U.S. government agency, and I was the lead for the team. I'm not the cryptographer, but I led the team of folks to come in and say, how are we actually going to make this work? I keep this very handy because that is the short URL. You can also, if you just Google Hyperledger Indy DKMS, you'll get right to that document. It's a 65-page document that explains the whole architecture and goes super deep, have lots of other references. But here's the essence of how you're actually going to recover your wallet if you have a problem, okay? There are two basic options. They're known in the industry as offline recovery or a paper wallet, and social recovery that uses a trustee. The first one is well known, it's been out there for a long time. Both of them depend on the same thing, which is, this is an iPhone. I turned on the option that it's automatically backed up to the iCloud, okay? I'm not gonna do the question right now of how many people also have the same thing, because a lot of you may not even know that, right? My wife once lost her phone and was absolutely, fit to be tied. And she called me, from a friend's phone and just said, what am I going to do? What am I going to do? I said, we'll get a new phone if we have to. And she's like, well, what about all the stuff that's on it? I was like, it's been backed up to the cloud the whole time. So it's not a bad idea. Part of DKMS is basically going to say, if you want to do a DKMS wallet, you need to build into the wallet the option, not the requirement, but the option that it's automatically backed up to the cloud, an encrypted version of it. Right? You don't want the keys out there anyplace else, and it might even be split up among multiple locations. How do you get it back? You need a recovery key. You need a special key. You need to pull the wallet back down into a new device, and you need a recovery key to unlock it. So there are two ways to, I want to show you this. Again, for the technical folks, think these agents that are helping you communicate all this stuff. They're either out at the edge on your device, or they're what are called cloud agents. And this is where that backup copy would be stored. So as you're forming relationships and doing things up there, it's keeping it backed up there. And then, if you lose the device, you need one of these two options, okay? Offline recovery says, okay, what you do when you set up your wallet, you print out a QR code, or you save it on cold storage. Every one of you that's using a crypto wallet of some kind for cryptocurrency, you're doing the same thing. Or you're really living, on the edge. Yes. Now, with DKMS, with self-sovereign identity infrastructure, a whole second option is there. And we spent a bunch of time researching, and then we built this and we demonstrated it to the US government agency that we're doing this work for. And with social recovery, you don't need to store a QR code or maybe lose it, or put it on cold storage or maybe lose that. What happens is your device, through your cloud agents, actually takes that recovery key and splits it into different pieces and shares it with your trusted contacts. You pick those contacts, you can pick the number, and then the number you need to recover from. It's called M of N, right? You can say, all right, I'm going to give it to 2 people, and I just need 1 of them to give it back. Or I'm going to give it to 10 people, and I need 7 of them to give it back. And I say people, these can be organizations as well. We have banks, and in the US, what we call credit unions, that are saying, hey, wait a minute, we want to start offering that service to our customers. We store their money, why don't we help them store the backup for their wallet? So lots of different options with the social recovery. I think you can see how with self-sovereign identity, with smart wallets and agents, this is now something it literally should take you a couple minutes to set up, and you'll never have to worry about it. And if you lose your phone, there's a safe way to recover, and you're not putting your keys at risk. Okay, I'm going to cover a couple more things just to give you a sense now of, okay, where is this going in the larger market? Now, first, I want to give you a picture of this infrastructure we're talking about. Again, it's not specific to any one project. It's not a blockchain someplace. It's like a layer on the internet, very much like the web was or that email was. It's interoperable. The bottom of that layer is the public blockchains, where you need to find those DIDs to sign those credentials, okay? The next layer up is those agents and wallets. Again, every device, within a few years, every device you use should start coming with one of those interoperable wallets on it, okay? Either you download it or it will start coming with the device itself. Those 2 layers together give you what we call cryptographic trust. This is how you know that you have an encrypted connection and that the messages are secure, the keys are valid, okay? There's no human trust yet at this layer. To add the human trust, you go to the whole layer above that, and the first layer is the credentials. The issue, who issues them, who gets them. Every single credential we use in a wallet like this today can be issued digitally. And I'll stop right there and tell the first story that I just came from what's called a Hyperledger Global Summit. It's the annual all-community meeting of the Hyperledger community. It was in Basel, Switzerland. And about half the conference was about self-sovereign identity. That's how popular it's become. The government of British Columbia in Canada came to do several presentations and an announcement that they had built a system up there of verifiable credentials. It happens to work on the sovereign, uses sovereign DIDs, where every government agency in the province of British Columbia, the agencies that issue your corporate registrations, health certificates, building licenses, all of the licenses that a business needs to get in British Columbia, which currently you get on paper or plastic, they have developed software, so all of those agencies, that same credential is going to go, digital version, verifiable credential is going to go to a service they're operating, they call the org book. And it means there's going to be a publicly searchable database of every verifiable credential, every license issued for every business in British Columbia. And you will not only be able to go and look and find them, but you can then ask for a cryptographic proof that that is a credential issued by that agency. It's not an experiment. It was an experiment a year ago. They announced the production release. British Columbia has issued 1.5 million business credentials. They took their whole database, they registered a couple of DIDs on Sovereign for them for the issuers, and they converted it. It's about 12 hours of cryptographic processing. It's done. They got a sister province, Ontario, and they announced they converted theirs, over 5 million credentials for businesses. So this is now operational, and it's going to become part of the Canadian government infrastructure. So this is, This is happening. I'll talk in a minute about another initiative from the credit unions in the US. So again, anyone can issue, anyone can hold, anyone can verify a credential. The other question that starts to come up is, okay, so if I have the digital equivalent of this driver's license, and I go show up at some retail site on the internet, and they say, yeah, we'll accept digital credentials, and I give them a proof of this one, how do they know that it came from Washington State, the Washington State Driver's License Authority, right? I could come up, the software is all open source. Someone could issue that credential and just say, yeah, look, you see, it's the digital equivalent of forging a driver's license. Well, for that, there's one more layer, and we call it governance frameworks. And I won't go into the details of those terms, but the concept is pretty simple. If on the internet you wanted to confirm that Washington State Driver's License Authority is actually part of Washington State, which is actually part of the US Federation of States, all it takes is 2 credentials. And ultimately it rolls up to the US government can say, here's your credential, you're a state, and the state can say, here's your credential that you are the Washington State Driver's License Authority. If you set that up, it's called a governance framework, and what we're creating, the Sovereign Foundation, will allow anyone to create a governance framework, right? Anyone can produce their credentials. So we'll go from the relatively small number of what are called certificate authorities. When you are in your browser and you go to a site that has a digital certificate, right? You see the little lock in your browser? There are only about 200 of those around the world. And there's only 4 companies in the world that determine that those 200 are going to be recognized. They are the vendors of your browsers. Our trust in the internet today, the entire trust infrastructure of the internet depends on 4 browser vendors, and they make their own independent decision about what certificate authorities they recognize. I heard a story just last week in one of our working groups of a US government agency kicked out by one of the browser vendors. Just said, you're not doing your job, you're not organizing your agency the way you should. Our browser is no longer going to recognize your digital certificates. That's a browser vendor telling a government, no, you can't be part of the trust infrastructure. So here under this infrastructure, every trust community, as we call them, be it a government, right, financial institutions, university or a group of universities, or the International Federation of Universities, churches, employers, they can all have their own governance frameworks. It's a powerful new tool for making all of this work, what we call the web of trust. Now I'll finish up just by telling you the idea of a governance framework is, again, not theoretical. At the Sovereign Foundation, I chair the Governance Framework Working Group, and we have over 30 people, including 2 law firms, and we're now a lot more lawyers. Lawyers are looking at this going, huge dollar signs, right? Whoa, this is the future, I gotta get in here. Also, of course, GDPR and privacy experts. And the first version we created July of last year, that's what the Sovereign Network's been operating under. And version 2 of that framework we've been working on for last year was just approved at a board meeting immediately before this one that I attended remotely from here. So Alex and I are going out for dinner after this, and I'm going to buy a round of drinks for everyone who wants to join us. If you're interested in looking at it, that's the URL. It's in the Sovereign Foundation site. You can read every doc that's part of it. And here's the important thing. We've been building this. It's legally architected so that it's a foundation for other governance frameworks. The way to think about it, I have 2 boys, they're both in their 20s now, but as they were growing up, we had enough Legos to build, a city this high across this entire floor, right? And when you buy large Lego sets, you get this really thin baseboard that they come with, right? That's what the Sovereign Governance Framework is, this baseboard that you build other governance frameworks on. We call them domain-specific governance frameworks. And I'll give you some examples, okay? One we're working on right now is I know you don't have credit unions over here, but are you familiar with the term? It's a financial cooperative for doing banking, but it's nonprofit. In the U.S.
But they went bankrupt. It's the savings banks.
Yes. Did a little better in the U.S. They have about 9% market share. It's not huge, but there are about 6,000 in the U.S. There are about 89,000 worldwide. And they have formed an association called CU Ledger just for blockchain applications for credit unions. The first application is self-sovereign identity. They're going to create a standard digital credential for credit union membership. Any credit union is going to be able to issue you a credential if you're a member of that credit union. We're working through the user experience with them right now, but just imagine you walk into your credit union to do something and there's a poster next to the teller as you're waiting in line. And it says, scan this QR code, get your digital wallet, and by the time you get up to the line, you've downloaded the app, the teller's sitting there, she'll check your identification, say yes, you are a member, hit a button, and it'll download your MyCUID into your wallet. You will have the first, not just self-sovereign digital credential, but the first backed by KYC, know your customer. Imagine going to a website saying, I have a credential that can prove who I am from a financial institution. And they're doing this worldwide. And we're already, I'd say, about a third of the way through the process of drafting that domain-specific governance framework. So that there's a standard set of rules that any credit union worldwide can follow to issue that credential, and the verifiers out there will know, here's what I can rely on, right? Another example, in the United Kingdom, a company called True, started by a doctor, actually 2 doctors. In the United Kingdom, they have nationalized health service. So, I know it's more common here in the US, than in the US. But part of the problem in the UK with nationalized health service is doctors can be assigned any place. The process of checking in, going to a hospital or health facility, verifying that you are a doctor, you're the right doctor to be there, they're saying it takes up to 15% of a doctor's time to deal with that credentialing issue. And there are significant problems. There are doctors there that have managed to spoof that system for years. One of those doctors, a fairly young one, very tech savvy, just said, this is ridiculous. A couple of years ago, he said, we've got to come up with a better way. And he started looking around, found out about self-sovereign identity, and said, I'm going to build a company to do that. It's called True. It now has the National Health Service, the General Medical Council, the Postal Service in the UK. They've all signed up. They're doing trials right now. It will go live in 2019. There will be a way, any doctor will be able to, with verifiable credential, walk up to a new hospital, scan a barcode, and within seconds, they will know that's really them. And remember, it's biometric verification on your phone, okay? It will save them millions of pounds, and more importantly, like 15% of the doctor's time. Just think how many lives are actually going to be helped there. Another example, international travel. We all know, what a hassle it can be, the time you spent waiting in lines. And then, of course, fraud and crime prevention across international borders. One of the first industries to pick up on self-sovereign identity was the travel industry, especially companies in Switzerland that help coordinate that. So they're looking at another governance framework. Medical records, another obvious one. There are many more examples, but this is, you get the general idea. Every one of those frameworks, they develop the framework, and now a set of issuers can give you a digital credential, and you can enjoy the benefits as an individual, and so can every business that now is cutting down their costs and cutting out their fraud and increasing their satisfaction for you as a customer. That's what's driving this industry forward. This is my prediction. I'm going online here. This whole thing's being recorded. Within 5 years, we will see more than 100 governance frameworks out there, and you will be getting credentials from them. Probably somebody in this room will have started one of those governance frameworks. If you do that in that period of time, please write me back. Tell me, yeah, I heard about it there, and we went to do it, okay? So, in conclusion, I hope you understand now why blockchain is the key to this whole revolution in digital identity, and join us, help us, Sovereign foundation, open standards, open source. We can build this together. We can finally have a trust layer, which I probably don't need to tell you we could use for the internet these days. Yeah? All right. Thank you very much, and questions away.